In the Credit Hours tab, the question says, conduct the appropriate statistical analysis to determine if we can predict, there it is, the word predict, so now we know we're running regression. Predict the number of credit hours, that makes it our Y, that people are enrolled in based on their age. So the age is X. So we know we're predicting the number of credit hours, that's our Y. Based on their age, that's X, and we're running regression because we are trying to predict something. So I went ahead and did that already. So here's the output that I got. You guys can run yours, make sure your numbers match, and then I'm going to go ahead and scroll down. So you can pause the video here, go ahead and do that part, and then we're going to work on the prediction table. Okay, so we're in the prediction table. What is a prediction table? Well, remember that we just used the ages and ran regression to see if we could predict the number of credit hours. If the answer is yes, it's yes. If the answer is yes, then let's go ahead and make some predictions. So what does this mean? Well, we saw the ages, and based on those ages, we could predict credit hours. So let's take these ages and see how closely we can predict their estimated number of credit hours that they're taking. All right, maybe you fit one of these. See if it fits you. We always start in the middle of the prediction table, and to get the estimated credit hours, we're going to use the regression equation, and that's always the same thing. Okay, so to get the estimated credit hours, or the estimated amount, we are going to take the intercept, so select that, the coefficient intercept, and we are going to add to that the age times the age coefficient, because that's what we're trying to predict, or that's what we're using to predict, excuse me. So we are estimating that the credit hours would be 16.43, and I believe it tells us somewhere to change that to one decimal place. If you're not sure, use the hints, they'll show you. So I'll go ahead and adjust that to one decimal place. Now before I drag that down, some of these need to be locked and some of them don't. So which need to be locked? Well, we want the age to change. So I don't want the red, I leave that alone so it does change, but I'm going to lock the other two. This is where the color coding comes in really handy. So leave red alone. The other two we want to be absolute references. So I will lock the row number. And then I can drag that down. Check that that's 15.9 for mine, and that's correct. Okay, now let's work on the lower and upper scale. So what we're trying to figure out is, can we be 95% certain, or we want to be 95% certain that the number of credit hours is going to fall between the lower and the upper range? So we're going to go ahead and calculate this. And to do this, we're going to take the estimated credit hours, and on the lower end we subtract. And what do we subtract? We subtract 2 times the standard error, and the standard error is up here. And remember, the standard error is just telling us how much the predicted value is going to differ from the actual value, or what we think it will anyway. 12.8, go ahead and format that. You can lock those cells and drag them down, and then on the upper side we do essentially the same thing. We're going to grab the estimated credit hours, but this time we're going to add, because we had a lower range, subtract, an upper range, add 2 times, again, that standard error. Oops. I got 20.1, it's telling me that's correct, so I can format. Make sure you lock your cells appropriately, drag it down, answer the questions, and you can move on and do the same sorts, use these same techniques on the remaining tabs.